A deficiency of logistic regression is it is a binary classifier. It only works as it is written for situations in which you have two classes, 0 and 1, yes or no, true and false. There are other classifiers that also have this same deficiency, and there are other ones that naturally handle multiple classes. Now we can go ahead and do something. We can modify these binary classifiers such that they can work with more than two classes. There are two common schemes to rectify this deficiency, to fix this problem. And one of them is the one versus all, and the other is the one versus one scheme. For this example, let's consider a situation in which we have image classification, but we have 4 different classes. We have whether the image is a cat, a dog, a duck, or a rabbit. In the one versus all scheme, we're going to train K classifiers, where K is the number of classes. So in the example I illustrated, we have to train 4 classifiers. 4 binary classifiers. Let me just sketch that out. So what we're going to do is we're going to train one classifier will be whether something is a cat versus not a cat. The other classifier we're going to train is dog or not a dog. Rabbit versus not a rabbit. And duck, which I'll abbreviate with P, versus not a duck. So this is where the model gets its name. This scheme gets its name, the one versus all. Because we're going to, the classifiers we're going to train, they're all binary classifiers. But they're set up as this class, this one class, versus everything else, all the rest. Let's move on to the other class. This class versus all the rest. And move down and so forth until we've covered all those classes. So that's where we're going to train K classifiers, in this case 4 different classifiers, and they're all set up as one class versus the rest. One versus all, hence the name. Let's consider the one versus one scheme. Well, let me go ahead and I'm not quite done with this here. Once we train all these 4 classifiers, how do you make a prediction? Or how do you make a probabilistic prediction? What you do is you can go ahead and use the first model. And let's say the model says, reports out 65%. So it says it's 65% certain that this image is a cat as opposed to not being a cat. Okay, and before we jump to conclusions and say, okay, the image is a cat, let's go investigate how the other models perform. And then let's say this one is 30% that it's a dog, and let's say a rabbit, it's 20%. And the last one returns 80%. Then what you need to do is you need to combine these values. You need to reweight these values. So what you're going to do is that if you want to understand or figure out what is a probability this image is a cat, you don't say 65. You got to consider all the other values it returned. So you got to do 65 over the sum of all these numbers. You have to reweight your probabilities, renormalize them. And you do this for all the other predictions. So you got to make sure you reweight this. So that's what this f of k represents. F of k represents a probability from one of those classifiers, one of those k classifiers. And P of k represents the final probability once you apply the reweighting scheme, the normalization scheme. In that case, when you do that normalization scheme, you add up all the probabilities, you should get a value of 1. So 1 versus all. Let's discuss the 1 versus 1. So in 1 versus 1, you're going to train classifiers between all the different pairs. All the different pairs of comparison. So in other words, cat versus dog, cat versus rabbit and cat versus duck. Okay, let's consider other pairs as well. So we can also do dog versus rabbit and dog versus duck. And we also have rabbit versus duck. So we have laid out here are all the pairs we can train. In this classifier, you're only going to train one class versus another class. One versus one. Not one versus the rest, one versus one. You're going to pit one class against another. In this situation here, these are all the pairwise we can have. So the equation where you what's going to end up happening is that you're going to train k times k minus 1 over 2 classifiers. So let's go ahead and insert 4. In this example, we have 4 classes. So 4 times 3, that's 12 divided by 2, 6. So we're going to train 6 different classifiers if we use the 1 versus 1 scheme. And we count it, yeah. Indeed, we have 6 distinct pairs. And notice, we don't do the reverse. We don't do dog versus cat because that's the exact same thing as cat versus dog. So yes, in general, we're going to train more classifiers if we use the 1 versus 1 scheme. And that might be a problem. You might be concerned because if we understand the more models we have to train, the longer it's going to train, the longer training time we have overall, right? We train more models and slow down our training time. There's more models to train as opposed to the 1 versus all scheme. But in the 1 versus 1 scheme, each classifier is being trained on the full data set because it's 1 versus the rest. This class versus all the rest. So all those K classifiers, they get trained on the full data set. But the 1 versus 1 scheme, let's examine it. Are you using the full data set to train each classifier or only using a subset? You're only using a subset. Because we look at it, it's cat versus dog. So only the data that's going to go into this model to train this model are only the observations belonging to cat and dog. Let's do cat versus rabbit. You're only going to include observations for cat and rabbit. So even though the 1 versus 1 scheme, you're going to train more classifiers, each classifier gets trained on only a subset of the full data set. And that matters because the training times for these algorithms often scale with the training size. How many training observations are in your data set? So certain models might be overall take faster to train if you do the 1 versus 1 scheme as opposed to the 1 versus all scheme. In scikit-learn, when you use these models, these binary classifiers, there is an option to set whether you want to use the 1 versus all or the 1 versus 1. Usually, the default has been set that the better one to use for that model is the default. But you should consider that when you look at the documentation. You can see that keyword argument. We can modify which scheme you should use to do multi-classification.